Thank you. And it's an honor to be here, an honor to be being able to present with everybody today and share a little bit of our experience and how we were able to bring CAD/CAM into our office and the successes that we had with that, especially being able to work with a fantastic team with Roland and DG Shape. And as part of that, I would like to share a little bit about the team. I'm Dr. Alan Jurim. I work in a practice both along with my sister, Dr. Barbara Jurim, and we have grown up in the background of the dental laboratory industry. Our parents had run a successful dental laboratory, and so we were in the right place at the right time to help start taking different parts of technology and bringing them into the office, and also allowing us to evaluate which technology is really best for us to enhance the patient experience. And we've had the most success, the most fun with this process, and that's really what we want to be able to share with you today. I am going to turn off the webcam for a moment, and we're going to go more into the presentation here. I wanted to take a second. Let's hold on here. I wanted to take a second and to acknowledge the team, and Dwight Blair and James Babby with DG Shape have been incredible partners for allowing us to produce this style dentistry for our patients. And I think it's a very, very important part that we focus on the team. And the results that we've seen with DG Shape and with Roland are top for us. And so it's a very important part of just how we want to operate. And I thank you for their continued support. Our goal for today is to go over some of the different aspects of DG Shape milling and how we were able to bring this into the practice. I'm getting a little feedback. And we're going to discuss CAD/CAM materials, and we're also going to discuss some of the digital trends that are really taking off in 2018 towards the technology. So my background before dentistry, before becoming a clinician, I actually went to engineering school. I was fortunate enough to spend some time at RPI and study computer systems and electrical engineering. And the technology has always been an important part of my background. I was fortunate to graduate from NYU in 2008 and be in the right place at the right time where technology was really taking over dentistry. We saw this in the laboratory, and the laboratories were first to adopt this, and now we're really beginning to see how it's taken place and taken hold in the dental practice. This was my desk in dental school. Believe it or not, I never left my engineering background behind, and I've always loved it as a passion. Here's our team. This is myself on the right, and the beautiful lady in the middle is my sister, Dr. Barbara Jurim, and Dr. Brandon Katz. So we're a team here at Integrated Dental. This is our practice, and what we really focus on is trying to provide the best quality dentistry that we can to our patients. And the quality of dentistry is not just how well I produce a restoration, but it's really the experience that the patient has. And all of this ties back together for us to really enhance that experience, because that's what patients really take home is their experience. We grew up in the background of the laboratory, so Jurim Dental Studio was our CAD/CAM laboratory, and it was always in a separate location for the past I would say around 6 years when we had opened up our practice. And we took on a challenge where we wanted to combine the two of them, and we put the practice and laboratory together like what you see here. And part of that, the reason was because we wanted to share a lot of the experiences, for example, what we're going to share with you today, of just why we do something a certain way and the results that we get and how we were able to do it. And that's where we really began developing our academy, which was a place for us to share those experiences. So this is as we were putting the place together. We had taken this entire building, we gutted it out, and we began building both the practice and the laboratory. And because they were in separate locations for so long, we began to see and we began to use digital dentistry and our roll-and milling machines in a way where the laboratory was separate than the office. And we had a very good foundation with digital dentistry, and it was the next logical move for us to take that technology and bring it into the practice for chairside CAD/CAM dentistry. This is where we currently are right now, and this is where we like to share all those experiences with the Academy. And the process of taking all these different steps and evaluating them and allowing the clinicians to see the laboratory side, allowing the laboratory to see the clinical side is all about what we are, which is to enhance that experience and to enhance our level of education with digital dentistry. So we've really been able to maximize and take forth a lot of the latest trends in comprehensive dentistry and CAD/CAM same-day dentistry and share that with our team. Another very important part of this whole process of integrating CAD/CAM dentistry into the practice has to do with education. And so we're heavily involved with Toro College of Dental Medicine, which is a new dental school in New York State. We're on our second class. In fact, our third class begins this year. And what we've done at Toro and what we're very excited about is supporting the students with the digital ecosystem, with the tools they need for practical experience when it comes down to digital dentistry. And that is not just any intraoral scanning system. It's not a design system. It's not a manufacturing system like a milling machine or a printer. It's really how everything is accessible in an ecosystem so that the tools of digital dentistry can really be performed. And taking this and giving this access to the students and to the faculty is where we've had the most fun. And so I wanted to also acknowledge Sunil Abraham. So this is Sunny here on the left-hand side. Sunny is the Director of Technology here in our academy, and as well as with my laboratory and office. He's a very big part in us being able to put together this webinar today, as well as share some of those workflows of how we're able to be successful with the chairside dentistry. So our process for digital dentistry began in 2012. And in 2012, we took that plunge into digital dentistry. What we wanted to do is we wanted to offer better services to our patients. And that began with us using the CEREC system. And the CEREC system was a good system for us at the time because it was a closed architecture system. And what that really means is that they took a very complex series of steps. For example, scan, design, CAM, and then mill, and they made that into a package that was very easy for the non-technical user to more or less go next, 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 and produce a same-day restoration. And CEREC did okay for us for some time, but we easily outgrew it. And that was because we really wanted to provide more services to the patient and use that technology, not just chairside, but also use it as we wanted to share within a laboratory workflow. And that process of bringing the digital chairside dentistry to the practice allowed us to do cases like what you see here, where we're able to take a patient and do a smile analysis and end up with a series of restorations that enhances the patient's smile. But what's changed for us between 2012 and now is the steps that happen in between, how we end up at the final stage, how we're able to produce this for a patient, how we're able to analyze, is this a case that is best for us to do chairside with our skills and techniques in office, or is this best to be collaborated with a laboratory team? And so most of our experiences really come down to a couple of very important points. And the first is the team aspect. And I'll always come back to this, saying that the team aspect or the team approach to any sort of dentistry, especially digital dentistry, is incredibly important. It's the team that has to accept it, it's the team that has to work together, and it's the team that's going to have it ultimately produce the results that we're looking for. And most of it is tailored towards that experience. The patient experience is one of the most powerful parts of improving the service we provide to our patients. Most patients don't know how well I prep the crown. They don't know how well my onlay prep is, but they know about the experience they have when they leave the practice. And if we can take that experience and we can maximize it, minimize the amount of appointments, and give patients a better service, which what I think is the best fitting restorations in dentistry, we really have a win-win many different ways. We're hopefully then can tie emotion into their dentistry. And with emotion, we want to be able to develop passion. And when we have all these elements together, we're really able to, kind of bring it to the next level as far as what our plan is, and to share those techniques with our patients, share the services, as well as share them with you today. So let's take a closer look at some of the fundamental tools for digital dentistry and how we've incorporated these into our practice, as well as I want to end with a case that shows kind of how we take all these different parts and we combine them. So photography still remains one of the most important foundations for us in providing the restorations and providing the proper style dentistry to our patients. We also work with intraoral scanners. Now, intraoral scanners these days more or less are all open systems. And what we mean by that is that we can take a scan with a 3-shape intraoral scanner, we can take a scan with an iTero scanner, we can take a scan with a CEREC scanner, and all of these can be adapted to what I'm going to be able to show you today. So this technology and these systems are not really proprietary these days to saying that you have to use this one, and you can only do this with that. In fact, everything I show you here today can be done with almost any scanner that's available on the market now, because they allow us to take those scans and bring them into other parts of the workflow. And the third most powerful tool of digital dentistry these days are 3D x-rays. And once we have these three tools available within the practice, we begin to open up the realm of what's available within digital dentistry. And in order to be successful with the chairside dentistry, I always think it's a good idea to begin somewhere and then expand upon that experience and that level of education. And so we began like this, and we then began bringing the technology of milling into the practice. But I always want to take this time and I want to explain what I think are some of the really important parts of the digital workflow. And first one is very similar to what we're doing here today. Anytime something is on a computer screen, we have a virtual collaboration and real-time support, almost anywhere around the world. And the ability to share information in real time like this is incredibly powerful. In fact, a lot of the services that are available for same-day CAD/CAM dentistry these days even will offer and maximize and leverage this virtual collaboration to allow experienced designers, experienced lab technicians to actually connect to your system, do a design, produce a restoration, or a restoration that can then be fabricated in-house. So there's a lot of very cool aspects to how we can mix and match, but once we have a digital scanner, once we have this information on a computer screen, we now have the ability to really enhance these collaboration efforts. There's other techniques out there, digital patient monitoring, where we can now use the scanners and we can use scans from different points in time to really teach us about how a patient is changing over time. And this becomes a very important part because we're going to be seeing a very big change in the adaptation or the adoption of scans into the office. And this is a very powerful part, the ability to take a scanner, to take any information that's digitized, compare it, and begin to see changes that happen. And so a lot of times the idea is we're not just going to be using this technology for one aspect of dentistry. We're going to be really redefining how we practice. And I think we're going to see a couple more examples of this throughout today's presentation. Dynamic impressioning is another really important part. That's where we can take a scan and we can actually build the perfect scan over time. In most of my same-day workflows, while the patient is being anesthetized and is getting numb, we're actually scanning the patient at that time, and then we're going ahead and we're actually cutting away part of the rest of the scan, and we're only scanning in our preparation once the time is ready for the final impression. We also have the ability to do other great things with this stuff now, but the point is that we can take scans of our patients and we can use that in real time to design the restorations while also being able to be very efficient in the process, so that we want to make sure that when I see a patient, I have 2 hours with that patient for a same-day restoration, and I want to make sure things are working like clockwork. So there should be no downtime, and we're going to leverage this technology so that while the patient's getting numb, the assistants are scanning. By the time we are prepared our tooth, my job is to come in, make sure it's prepared properly, and to record that information very accurately and be efficient in that process. And the last important part of any digital dentistry or anything digital is the ability to align different data sets. This is the real true power of digital dentistry. It allows us to take different elements, compare them, combine them, and have a lot of information available to give very patient-specific treatment. So there's always been this restorative need for CAD/CAM dentistry. And in fact, most ways that we're working with the same-day workflows was for a restorative purpose. The patient needs an onlay, no problem. We're going to prep that tooth. We're going to clean it. We're then going to scan that patient, and we're going to produce a restoration for them while they wait. Incredible benefits, and I'm sure, well, I'm not sure, but most of the time patients have heard this, participants have heard this before. The real benefits become that we don't have multiple appointments. Patients don't need to have provisional restorations, and we can actually cut down on the amount of chair time it takes us and expense to, end up with that final restoration with the patient. But there's always been this restorative process, and the restorative process has been greatly simplified by the ability to have digital information travel around the internet and around our global communication networks, so that, yeah, if you're going to see a patient and you're in California, you like to work with a gifted technician who's in Brazil, you can scan that patient. You can have your Brazilian ceramist take that case. They can design it, and they can send it to a mill, or they can send it to one of the Roland manufacturing machines that's actually within the office. And this is something that I think is going to be one of those digital trends that you're going to see that gets greatly developed, because not everybody wants to become a designer, not everybody wants to become an IT technician, but they want to be able to get the best parts of the digital workflow and take this number where you see 3 days and reduce the amount of time it takes to give this patient a great restoration. So this is a typical workflow that we were seeing. A patient would come into us, they need a crown on tooth number 3. We would see the patient, we would prepare the tooth, we would then scan the tooth in. We would always, check before the patient is going to be dismissed. And this is not a same-day workflow that we're doing here, but it's important to see what we're looking for. And we would take this information, put together a beautiful design of a nice crown that has secondary, tertiary anatomy, whatever we're looking for. And this would then go off to our manufacturing. And we would have one machine, a Roland dry mill, that would be producing the zirconia restoration, another machine that's producing a model. Everything comes back together, and within 3 days we can transfer this restoration to the patient. So the patient would come back, remove the provisional, and deliver a final restoration. And what happened as part of this process is that, well, it began to be very apparent that if we wanted to provide the patients with a restoration sooner, it really was dependent on the type of material. And there are some materials in same-day CAD/CAM dentistry which are really tailored towards that workflow, and there's some that aren't. And the reason why I'm showing this case is because this is a zirconia restoration. And I want to make it clear my opinion that I never think that zirconia is ever really truly going to become a good chair-side CAD/CAM material. And the main reason is because of the complexity that goes into producing a very nice zirconia crown. It has to go through a special firing cycle. Sometimes it goes through a longer mill cycle. But also what ends up happening is that this zirconia has to be treated very special before it gets fired over a long period of time in order to achieve the properties that we want. So we use zirconia on a daily basis, but we do not use zirconia for our same-day CAD/CAM restorations. We use a different Roland milling machine, a dry mill that is really made and kept for zirconia. And the important part about it is that we wanted to be able to use the same technology that we're using for our chairside restorations to also be able to produce restorations like this crown you see here that involves a laboratory. So we always have to be able to have that determination, have that insight into choosing which avenue, which route, which workflow we want to use to produce this restoration. As we go through, there's a lot of different benefits to some of the different mills that are available to us. Now, these are the most common mills that we use on a daily basis. The first one that's on the left is a dry mill. Also the one on the right, which is the DWX52DC, not the DCI, Roland, although I know that Dwight sent me a picture of the DCI. It's in a different slide. These two mills that are on the far ends are primarily used for dry milling. So we'll use that to mill acrylic or polymethyl methacrylate, and we'll use that to do zirconia restorations. Now, the one that's in the middle is our key mill, and this is the one that we use on a daily basis. In fact, right now, I kid you not, if I bring up a camera, I'll show you that I'm milling a couple crowns for patients that are waiting in our operatories. So we use the DWX4W on a daily basis, and that's really designed for us to have incredible precision and predictability in a milling unit that can produce a block style restoration. And when I say block, what I mean is that we insert into this machine either a piece of Emax, Ceresmart, Lava Ultimate, a lot of different ceramics that we can use to produce for our patients same-day restorations. The biggest difference between the middle one and the outer machines here is the fact that the middle machine is a wet mill. So we'll use water as we're going to manufacture with this machine. And we're going to have a couple videos that come up that show a little bit more of the manufacturing process. But these mills, the idea behind them is that they're incredibly durable. They're very non-complex, and what they allow us to do is to take these industrial machines. That's how we began milling in dentistry. We took machines from these big industry manufacturing, and we shrunk them down in size, and we started using them in dentistry. Well, we have the ability now to take those machines and make them even less complex, make them even prettier, and make them more reliable. And that's what Roland has done an incredibly good job for us. So what we see here is actually that same restoration for that patient before that I milled with our Roland mill and 6 different materials. So we have different types of zirconia, we have Emax, we have acrylic, but the idea is we took that same file and you see how we can take that same file and we can put it through and we can actually produce it in many different materials all as the same exact restoration. This was important because I was looking and trying to determine the translucency of the materials and see which one I, like best when I'm going to choose it for whatever scenario. So we've taken that technology and we use it on almost every single style case. Here's a case where we had a patient who came in who said he needed a single crown, and we ended up producing a rather nice series of prototype restorations. So these were done first in acrylic as our prototype restorations. And I don't say temporaries, I say prototypes because that's really just what it is. And we'll take that and then we'll go ahead and we will then finalize this. And here is the final zirconia. But we've used the technology on many, many different types of cases, not just on chairside cases. So we've gone from this restorative tool of using a digital dentistry for, and it's really shifting towards a very big diagnostic tool. And what do I mean by that is that we've developed and we've scanned patients over time, and once we've developed this big library of patients and we had an area set up for us to be able to take digital scans very easily and efficiently, this is one of our scan rooms where a scanner is built directly into a chair, is we've been able to use these scans to help teach our patients about what's going on in their mouth and about the whole entire process for them to understand and accept dentistry. So every patient who comes into the practice will receive a scan, and we will use these same scans to teach the patient, I want to show you, for argument's sake, look at the crack that's in this tooth, or look how this tooth has been changing, look how this restoration is going to be in necessity of repair. And it's a very powerful diagnostic tool that patients use to learn and to understand their scenario better than ever. We also have the ability now of taking some of these different tools, and as we're teaching the patients, the practice in the laboratory has really kind of merged. And this is where is the most exciting part of some of the changes in digital dentistry, is that in order to produce a CAD/CAM chairside restoration, it does involve someone in the practice, and normally it's the clinician or the head assistant who has become an expert in doing digital design, has become an expert in the manufacturing, has become an expert in a lot of different parts in order to have that predictable workflow. What we really love is the fact that we can have someone in the laboratory actually design the case and then send it to one of our milling machines. And that way, all the assistant has to do is load the appropriate block, and we're able to actually have out of the machine come out some beautiful same-day restorations. And this is what we typically see. We'll had a patient who had come in and had a deep carious lesion like we see here, and after the patient was treated with endo, at that point we were able to make a final restoration, and these are the results that we typically see. Incredible adaptation, really beautiful end results, and the final process of getting from A to B is not just exciting and fun, but also it produces what we believe is one of the best restorations that we could produce in chairside dentistry or in dentistry in general. So this is where we, these are the scans that we use for this patient. The design was put forth. It was then sent to a Roland wet mill where we produced an Emax restoration for the patient. And we were then able to deliver it the day he came for the preparation, which was after his endodontist visit. These are the real tools that we are using on a daily basis. And I hope to share with you a little bit of information on how we're able to do some of this, but I wanted to discuss a little bit more on materials. And so we have a lot of different great materials, and all these materials you'll notice work within a block system. And when I say block, what I mean is that it has this mandrel on the end, and that will go into the mill, and we're able to then tell the software this is the material that we want to use. And there's a lot of different benefits, but all of these ones will work and mill phenomenally well in a system like this. So we have our hybrid ceramics or our glass ceramics. In fact, Emax here is one of the older materials. Irrespective of Emax here, we see that we have on the left-hand side Sarah Smart, Lava Ultimate, and Vita and Namic. And these are the really exciting materials that we are using in dentistry these days. There's interior aesthetic high glass porcelain blocks. We have partial full coverage blocks. We have posterior high strength. And then we have our implant and provisional blocks. If we take a closer look, the interior aesthetic blocks are really Vita Mark II and Empress and GC Initial. And what these are very high glass content, and they give us a very translucent, nice restoration. In fact, the Empress multi-CAD, like what we see in the middle, is one of my favorite materials because it's a multi-layer block. It has built into it different layers of incisal translucency. It has different layers of deep body and chroma colors, and all of this will be produced on the machine, and we can actually choose where in the block we want our restoration to come out. Do we want to have it more with the incisal translucency or more towards the bottom of the block where it's going to have deeper chroma? Some of the other materials for the partial or full coverage, these are what we would use in some of the posterior areas for inlays and onlays. My favorite material is Sarah Smart and Namic. These materials mill phenomenally well, and they give us a same-day restoration that does not have to be fired in a ceramic oven. So we've done and had incredible results. We talk about posterior high strength, and I put the zirconia here. I really don't think that zirconia, like I said before, is a viable or a smart chair-side CAD/CAM material. There are companies that promote it heavily, and they want to be able to allow the clinicians to provide those materials. But in my opinion, it's not really indicated for use in the dental office. Celtra Duo is a material by Dentsply. It's an incredibly strong material. It's a hybrid of zirconia and lithium silicate that are mixed together, and there's some very good indications for it. But we have different areas where we want to use these different machines. Now, this is a machine, and this is one of the ones that we use in the laboratory, and the reason why this is here is because it shows you how big and complex this machine is. Almost is a scary looking machine. And when we compare it to the nice, elegant roll-in machines that we use in the practice, it was important for us to not just have the milling machine, but also have it a place where the patients can see it. Because it's quiet, because it's an elegant machine, it doesn't look like this big industrial complex behemoth, there's a lot of value to also having the patients experience the process of milling and share that experience. You know, most of the patients will actually take a short little video of their crown being milled, and they'll want to share that with other people. And this is an up-close inside view of how this machine will also work. One of the true benefits that I love about this mill also compared to some of the results that we saw back in our CEREC days is that it will use a series of 3 different burrs to mill this Emax restoration like what you see here. So because it's going to use 3 different burrs and it has an optimized strategy, what it allows us to do is really reproduce properly what's on the computer screen, like what is going to come out of the machine. So it'll use a 2.5 millimeter burr, it'll use then a 1 millimeter burr, then it will use a 0.6 millimeter burr to give that really fine detail and make sure that everything is going to fit 100% well. Going back again, and Dwight, here you go, here's your 52 DCI. So what we have over here are, again, you know, the different series of mills. And a lot of times it's very common is to actually combine some of these different mills. I know laboratories obviously do that, but there's also clinicians who are into that. And it's really because they want to be able to provide the whole gamut as they grow within the digital realm. And the main point is that, you know, DG Shape and Roland really allow us to cover every aspect of this digital workflow. And that's been incredibly exciting. You know, digital dentures are coming out now, and the process of designing digital dentures, milling the individual parts, putting them together, and this split mill process being supported by Roland is incredibly powerful because it is going to become the future of how dentures are made. The digital fabrication process has many benefits as well as less time and expense compared to some of the traditional ways. So it's one of those really important parts. To sum up, you know, the important parts here, and I don't want to run late because I can talk about this stuff for hours. We're good with time, good. Is that, you know, there's a lot of different elements that go into producing a successful same-day restoration. And for us, this is how I like to summarize it. There's the preoperative phase. This is before we begin with the patient, what information are we going to gain? And normally that consists of us getting our records where we're going to scan the existing tooth. I always want to scan what was there before I prep it, because it becomes a very important part for me to reference as I'm doing a digital design, or I'm sharing that information for someone else to do the design. Then we have the preparation phase where we're going to prepare the tooth, and then we're going to record that, and then we're going to do our final scan validation. We're going to double check that we have all the information that we need perfect. Then we have our design phase and our milling and finishing phase, and that's where we're going to be working towards producing the restoration, and then we come back to the patient where we're actually going to do our delivery. And the great part is that these two elements don't always have to happen within the office. And that's been one of the big revolutionary parts for us. In fact, we were saying, as I practice with my sister does not like to do digital design. She likes to scan, she likes to send it to the laboratory, but she likes the benefits of being able to provide those patients with those services. And so what she would do is she would go through these first 4 phases. She would scan the patient, prepare the tooth, check the scan, and then she would have the designer connect to the computer, design the restoration, and then send it to the mill in the office. And all of that technical work happened remotely, and then all she had to do is load the right material in the machine, take it out, and then deliver it over onto the patient. And that's been incredibly powerful. And a lot of the steps like we see here, we have our preoperative scans where we're going to scan the upper, we're going to scan the existing tooth and scan the bite. Then we're going to prepare the tooth, we're going to isolate, we're going to actually make our preparation, and then we're going to retract. And then we're going to actually do our scan. So we're going to scan, we're going to make sure that it's clean, we're going to make sure it's dry, we're going to turn the color off if there is color and check. Any areas we didn't record well, we're going to cut out and we're going to fill back in. For example, if we did not retract enough around the margin, and then we're going to finalize that scan. And this is the part where it's important that we verify this, and then we can share, and we could begin remotely bringing in some of the team to do a remote design, and or for the clinician or someone in-house to actually go ahead and do that design part. And with the design elements, we have our margination. We have to set our insertion direction, or the path that the crown is going to be delivered. There are certain tools to transform, morph, and sculpt our restoration. We're going to set our context and our occlusion, and then we're going to check it, and that's our validation. And once that process is done, we can then send it to the mill where we can go ahead and we can cam it. And camming is the process of the machine determining what moves it has to do in order to actually cut this block out of a solid material. We have block selection, so we're going to choose what size block we're going to need, and then we start our mill process. And once the mill is done, depending on the material, we're going to do a try-in, and then we're going to be able to take that and we're going to deliver that to our patient, and that will be one of the last steps. So I actually have, and I want to jump ahead to just one last case because we have, are we okay with time? Okay, so what I'm going to do is I'm going to jump to one case because I really like how this case kind of sums up a lot of these different parts. These cases are some of the same-day workflows that we've done for our patients. So this case first began where we had a tooth that had recurrence carious lesions around an existing composite. So we take the patient and we're able to excavate, and we're able to scan that, and while the patient is waiting, we go ahead and we do our digital design. And the process of design really should be quick and simple. The most important part to any CAD/CAM same day in-office milling success is really predictability. I know that I want to make sure that I am going to have my parameters dialed in so that by the time I design this and by the time I go ahead and I send this to the mill, I know what I get out of that machine is going to drop right in place, and it's going to need minimal adjustment, and it's also going to give us maximum results. So this is kind of what that process looks like of dialing those parameters. I know that if I have my contact pressure, which is a speck of red, and about 0.1 millimeters of pressure into the adjacent tooth, with my Roland DWX4W, I'm going to get a restoration that will just drop right in place and hit upon that really key word, predictability. That's really what I'm always looking for, is that I want these ones to always be predictable. So that's what it looks like when we take it and we cam it. This was milled in Lava Ultimate, so it shows you the millability and how and what comes out of the machine. This is the same restoration, just pictured 3 different ways. I didn't mill it 3 times. And what's wonderful is that we have very, very fine, crisp margins. And that's so important, that the process of manufacturing this is not just predictable, but we also need to see the results. We need to see the quality of the restoration, so that we can go from somewhere like this and we could end up somewhere like this, all within, you know, a sub 2-hour time period, and we have maximum efficiency, and we know that it's going to be very predictable and drop in place. I love how these ones just blend and drop in place, because it almost looks like they disappear. Last one as well to show. So here we're going to be doing 2 crowns on the lower right. We're also going to be doing 2 onlays on the upper left. So here were the restorations that were made with Emacs. And when it came down to doing the upper restorations, again, we began with excavating the teeth. We had a proper scan. I always check that we recorded very well deep down in these areas. If we begin with an accurate scan, we should end up with a very accurate fitting restoration. So we're able to go ahead, we're able to put together a digital design like what we see here. These are made with GC Ceresmart. It's probably one of my favorite materials these days, because the results that we get are really, really phenomenal. And after the design is done, without any adaptation or any fancy trickery, these are how they just drop in place. They just kind of blend in, and they do a really, really good job mimicking natural tooth structure and allowing us to rehabilitate the teeth as best as possible. I want to end on this point. I want to give us some time for some Q&A if there's some questions that we can field. I'm going to turn the webcam back on here. Oh, okay. So the question was, one of the slides shows a 3D printer and how it's used. So I guess I will touch upon this real fast. I might as well, because we have another 4 minutes, and within 4 minutes I can do a lot. So I'm going to go back to this presentation real fast. Here is a patient who came to us, and this was a same-day case where we began with the proper documentation. Patient had some photos that were taken. Patient ultimately told us that he wanted to have his smile, his one tooth fixed, and he wanted to make sure it's done in a way where people can't really tell. And so as part of the process of doing our evaluation, we look and we say, you know what, I'm not really certain this is a one tooth fix. I really think that we have to involve both centrals. So we begin with our scan, and we begin with, you know, all of the data that we recorded, and we begin combining those data sets like I was showing. And here in the process of combining those data sets, we're actually going to take the intraoral scan, a 2D photo, and we're going to align the 2 of those. And once this process has been done, and I call this my digital facebo, because we're going to align a 3D model with the 2D picture, we could begin to design a restoration within the patient's face, within their own dental facial profile. And I can do this live with the patient, or we could do this separate, but this begins to give us an idea of where we want to end up. And we'll take this information and we'll send this to a 3D printer. And like what we see here on the left-hand side is the original, on the right-hand side is our virtual wax-up. And we'll use that, and we'll take this and we'll actually transfer it over to a patient. And we'll then take this information, we will scan it in. We will also use this information just in the design process for us. Now, it also is very valuable because it gives me a guide on how I want to prepare the case. And so what we see here is us actually going ahead and beginning to prepare through our 3D mock-up, or our provisional mock-up that we produced from that 3D printer, as well as from the digital information. So we have our final preparations here. I know that and looking at the photos and analyzing the case, that we were going to use an all-ceramic restoration like Emacs, so my margins are super gingival because we're not doing crazy changes in shade, and I want to make sure they're cleansable. So we'll properly retract. We'll then go ahead and we will begin the scanning process. So if you look on the screen of where my scanner is, you'll notice that the assistant had already scanned the majority of the arch. All we're doing is going and now filling back in our preparations. And once we've recorded that in our shade information, now we begin that design process. And this is happening live while the patient is waiting. And so we're setting our margination. We're going to go through. We're going to ultimately end up with a nice final design that the patient can preview. And here the patient loved it. He wanted to have these nice little wear facets and movements so that it looked as natural as possible. And then we send it directly to our Roland milling machine. And so we will now come to the machine. We have an idea of the correct block size, and we will deliver or load the right blocks. These are Emax blocks into the machine. We tighten it, and now I slip. Watch, ready, slip. Yep, there it is. I've seen this video a bunch of times. So here we go. So now the machine is ready to start milling, and it will begin using that 2 millimeter burr, 2.5 millimeter burr. Then it's going to go to a smaller burr, and you'll actually see it's going to pick up the 0.6 millimeter burr. And that's really important for veneers or for anything where we're looking to really replicate the enhanced detail we have on the screen from the design. We actually want the machine to produce. This was one of my big, pet peeves with some of the other systems, is that the answers I got when the machines weren't producing what I was looking for is, well, you should change your preparation so that the machine can produce what you want. And that's the opposite. I'm looking to do what's best for the patient, what's best for the tooth, and have the machine accommodate towards those parameters, not in reverse. So after about a 50-minute milling cycle, both restorations are now complete. This is what we see from the mill. And then we can put them into a furnace to crystallize them. And we can go from here to here in the same day, same restorative period. And patient's thrilled. Patient got what he wanted. We're happy because we are able to provide a service that is unique, that is efficient. It also enhances that experience so the patients share it with other people, and it's a win-win on many different aspects. As long as you're working with the right team, and as long as you're working with the right company like Roland. So I'm really happy to be able to share those experiences, and it's just been an ongoing learning process for us, and it's been incredible. All right. Doesn't seem like it. I am, again, very glad to have had the time to be able to share with you guys. And thank you again to DG Shape by Roland. And I'm looking forward to more fantastic same-day dentistry in the future. And anybody, whoever has any questions, always looking to help and to provide. So thank you guys very much, and hopefully I'll see you again. Take care.